Uh, this is the next session of the basic of CPU lens. In a previous video, we learned about introduction, how a computer architect processor and knife, Turing to rule the moon, and today is what even called a cheat code. Programs run in user mode because they cannot be touched touched with the full access to the computer. User mode does its job, prevent access to mode of the computer, but programs need to be access to access I/O, allocate memory, and interact with the operating system somehow. To do so, software running in user mode has to ask the operating system kernel for help. The OS can help them implement its own security protection to prevent program do something doing any malicious. malicious. If you ever written code that interact with the OS, you properly recognize functions like open, read, fork, and exit. Below a couple of layer of abstraction, the functions on use system call to ask the OS for help. A system call is a special procedure that lets a program start transition from user space to kernel space from jumping from the program code into OS code. User space to kernel space control transfers are accomplished using a processor called software interrupts. During the boot process, the operating system store a table called an interrupt vector table (IVT). 8664 called this the interrupt descriptor table in RAM and registers with the CPU. The IVT map interrupt number handler code pointer. Then userland program can use an instruction like int with which tells the processor to look up the given interrupt number in the IVT which switch to kernel mode and then jump the instruction pointer to the memory address stored at the IVT. When the kernel finish code finish, is you an instruct like IRES to tell the CPU to switch back to user mode and return the instruction pointer to where it was when the interrupt was triggered. If you were curious, the interrupt ID used for system call on Linux is 880. You can read a list of Linux system call on the microcurries online man-page directory. Grapper APIs abstracting always interrupts Here's what we know so far about system call. User mode program can accept IO or memory directly. They have to ask aware for help interacting with the outside world. Programs can delegate control to the OS with special machine code instructions like int and array. Program can directly switch privilege levels. Software interrupts are saved because the processor are being pre-configured by the OS with where in the OS code to jump to. The interrupt vector can only config from kernel mode. Programs need to pass data to the operating system when triggering a shitcode. The OS needs to know which specific system call to execute alongside any data the shitcode is sending. For example, what's the file name to open? The mechanism for passing data, this data vary by operating system and architecture, but it's usually done by placing data in certain register on the stack before triggering the interrupt. The variance how system calls are called across device mean it would be widely impractical for programmers to implement cheat code themselves for every program. These rules also mean operating systems couldn't change their interrupt handling for fear of breaking every program that's written to use our system. Finally, we typically don't write program in raw assembly anymore. Programmer can be expected to drop down to assembly anytime they want to read a file or allocate memory. So operating system provide an abstraction layer on the top of these interrupts, reusable higher level library functions that wrap the necessary assembly instruction are provided by libc on Unix system and a part of library called DLL on Windows. Code to the library functions themselves don't call switch to kernel mode. They are the standard function calls inside library. Assembly code does um, actually transfer control to the kernel and is a lot more platform depend than the grabbing library subroutine. When you call exit 1 from C running on Unix system, that function is internally running machine code to trigger an interrupt after placing a system call of course and argument in the right register stack whatever. Computers are so cool. The need for speed. Let's get CISCE. Many CISC architects like x86 64 contain instruction designed for system calls created due for the prevalency of the system call paradigm prevalent prevalent Intel and AMD managed not to coordinate coordinate. Intel and AMD managed not to coordinate very well on x86-64. It actually has to a set of optimized system called instruction, shift go and shift enter, optimized alternative to instruction like INT x80. Their corresponding return instruction, shift red and shift exit, are designed to transition quickly back to user space and resume program code. AM, AMD and Intel processors have slightly different compatibility compat- compatibility with these instructions. Syscon isn't generally the best option for 64-bit programs, with while Enter has better support with 32-bit programs. Representative representative for the styles at RISC architects tend not to have such specific or instruction as for the RISC architect app. Silicon is based on you only one interrupt instruction for C code and software interrupts alike. I think Mark is doing fine. Wow, that were a lot. Let's do a recap. Brief, brief recap. Processor execute instruction in an infinite fast execute loop and don't have any concept of operating system or programs. The processor most usually store in a register determines what instruction may be executed. The program's code run in kernel mode and switch to user mode to run program. To run a binary, the operating system switches to user mode and points the processor to the code entry point in RAM. Because they only have the privilege to view the mode. Programs that want to interact with the world need to jump OS code for help. System codes are a standardized way for programs to switch from user mode to kernel mode and into OS code. Programs are typ- typically use these shortcuts by calling share library function. These grab machine code for either software interrupts or artifact specific shortcode instruction that transfer control to the OS kernel and switch rings. The kernel does its business and switch back to user mode and return to the program code. Let's figure out how to answer my question from earlier. If the CPU don't keep track of more than one process and the execute instruction after instruction, why doesn't it get stuck inside whatever program it's running? How can multiple programming at once? The answer to this, my dear friend, is also answer to why Coldplay is so popular. Clocks, while technically timers, I just want to shoehorn that song in.